Lesson 1.1 is on the basic building blocks for geometry, so it's going to be talking about the points, lines, and planes. The most basic figures in geometry are undefined terms. Undefined terms cannot be defined by using other figures. The undefined terms are the point, the line, and the plane. These are the basic building blocks for geometry. Should be something you are familiar with from when you covered your geometry unit in middle school. In the chart below, you can see that they give us the definition and also the diagram. We know that a point is just labeled with a capital letter. It actually has no size. It simply represents a location. And I'm going to tell you that they'll really emphasize how to name these figures. And if we are going to name a point, we are simply going to use a capital letter. So that would be the point P. A line, well, we know that a line in geometry, it has to be straight. It cannot have a curve. There are arrows at the end to signify that it extends in both directions forever and ever. In this case, if I was going to name this line, I could do it a couple different ways. They have a script letter here, a little cursive letter L, so I could use that and name it line L. Or I could use the points on the line, the X and the Y, and then I would have to put the symbol on top. So they give us those examples right in here, line L, or XY or YX, but we just have to remember to put the bar or the notation on top, something like this. Now, if there were another point on that line, let's say I had point Z, we only need to pick two letters to name our line. Any two letters, it doesn't matter. So I could pick Z and Y. I could say that's the line ZY or YZ, and that would be the same thing. But I would not pick all three. The third one is the plane. The plane is a flat surface. It also extends in all directions forever. We're thinking two-dimensionally. Sometimes I think about the plane as like your desktop or the floor of the classroom. And here I am going to talk about naming the plane. They give us a couple examples where I could use, again, that script letter or that cursive letter R and call it plane R, where we write out the word. Or you can pick any 3 points on your plane. And so here they have chosen to pick plane ABC. The order of the letters doesn't matter. It could be switched around. And even if there was another point, like point D on my plane, I could name that with that letter, but I'm only going to pick 3 points. I'm not going to use all 4. It still means the entire plane. Down below, we have a couple new vocab words. They give us the word collinear. When you say that, collinear, you should hear the word linear, which means line. K, L, and M are collinear, meaning they are on the same line. Coplanar, then, meaning on the same plane. Here they tell us that K, L, and N are coplanar. And in our textbook, sometimes they would have my plane sketched around it as so. I will point out if I wanted to name that plane, there's no script letter, but I could just simply call it plane KLN. Typically, I wouldn't pick the 3 points that are in a line to name my plane. In example A, we are trying to decide if we could name 4 points that are coplanar. Well, when I look at my example here, any 4 points that are on the same plane, I can see I'm going to have to use what I'm going to call the bottom of that triangular pyramid. So the points A, B, C, and D, and I'm just going to list them as capital letters with comma in between. A, B, C, and D. Question 2 says, are A, D, and E collinear? Are points A, D, and E collinear? Well, Collinear meaning they're in the same line. No, they are not going to be collinear, but if you see they are all this kind of side of the pyramid, I would consider them to be coplanar. Moving on to page 2. On the second page, they also discuss some of the basic figures of geometry. We have the segment, the endpoint, the ray, and opposite rays. Well, the segment, it's similar to a line in that it has to be straight, but it does not extend forever and ever. So a segment has endpoints. Here I can see my segment AB or BA. If I'm going to name it, I'm simply going to use the bar on top. Important to know that something like this and something written as so mean two different things. This is referring to line AB and this is referring to segment AB. So it's important that you put that notation at the top. The endpoints of our segment are simply that. They're just points, so they name it with a capital letter. A ray is a part of a line that starts at an endpoint but extends forever in one direction. So a ray will have one arrow telling you which way it is extending. Here I can see that my ray, the endpoint is R. That's my starting point. So if I were to name it, it would be the ray RS. And it's a little hard to see, but there is an arrow at the end. This would be the ray RS, and that is how we would name it. Opposite rays are simply two rays that have a common endpoint and they go in opposite directions. So I have the ray EF and the ray EG, and they form a line in the end. In example B, they ask us to do some drawing. I just ask that you do the best that you can and label. Can we draw a segment with endpoints MN? Sure, here's my segment. I'm going to put my endpoints and I'm going to label them. Now, if it were asking me to name that figure, that would be the segment MN, or I could name it NM. Opposite rays with a common endpoint T. Well, if my common endpoint is T, then I know I'm just going to go in opposite directions for my opposite rays. Maybe I would put a couple points in there of S and U, so I would have the rays TS and TU as my opposite rays, or maybe I would refer to the line as line SU. And finally, number 3, a ray with endpoint M that contains N. Well, my endpoint has to be M. It doesn't matter which direction my ray is going. But in the end, when I name that, I have to start with the endpoint. In geometry, we have statements that are given to us as truths. And those truths we're going to refer to as our postulates. Sometimes they can be a little bit confusing, but in our postulates, in the charts in the book, they are numbered. It simply means Chapter 1, Lesson 1, Postulate 1. Chapter 1, Lesson 1, Postulate 2. So in the first one, it says that through any 2 points, there is exactly one line. Meaning these 2 points here connected with my line, there is no other possible line that I could draw that would connect those points. If I am given 3 non-collinear points, there's exactly one plane that can contain them. So no matter what 3 points a person is given, they can contain them in one plane. And lastly, if 2 points lie in a plane, then the line containing those points lies in the plane. Meaning, if these 2 points are connected with this purple line also lies in the plane. It is touching that plane in infinitely many spots. On page 3, the last couple postulates, well, up at the top, if we were to sketch two lines intersecting. Here's my intersection point. Maybe I'm going to call that point M. Is it possible that those lines will intersect again in a second place? No, not if my lines cannot curve, right? So if two lines intersect, their intersection is going to be one point. In 115, it says that if two planes intersect, their intersection is going to be one line. That can be kind of confusing, but there's a great picture in our book on page 8. I'll show you. Two planes intersecting in one line. They kind of show that here on page 8 where my purple plane and my green plane are intersecting, and that intersection there is my line. Again, the very last part, they're going to ask us to do a little bit of sketching, and sometimes we have to do some three-dimensional sketching. And so we're going to go ahead and use a dashed line when we need to show the hidden parts of the figure. So in example 1, when they ask us to sketch a line intersecting a plane at one point, I have my plane, while my line has to go through the plane in order to intersect it at one point. So I'm going to have my intersection point here, and to go through there, I'm just going to use my little dashed line, and I am showing my line intersecting my plane at one point. Question 2 is asking me to sketch two planes intersecting in one line. Now that one can be kind of tricky to try and sketch. We'll see how we can do here. I have my two planes intersecting, and that intersection point where they would crisscross would be this red line right here. And again, kind of tricky to draw, but just do the best that you can. And finally, number 3 asks me to sketch two lines intersecting in one point in a plane, but only one of the lines lies in the plane. So if I have my plane and only one line was on the plane, I would sketch it as so. The other line then is going to have to go through the plane, but they need to intersect. And so it's going to be similar to number 1. I'm going to sketch this through my plane with my dotted dashed line there. And now I have two lines intersecting in one point in a plane, with one of my lines lying on the plane. So I hope that helps you with lesson 1.1. If you have any questions on the assignment, please be sure to stop in and visit with me. You can also check out the other online videos via the book's website.